I am going to show you how to set up systems of equations with story problems and for real world examples such as these ones on, and they're not limited to what's on these next few pages, but this will give you a start on how to set them up. Okay, so the first thing you're going to want to do is you may have to read each problem carefully, like maybe 1 or 2 times, maybe draw a picture, but use those words and phrases that we learned in chapter 2, and hopefully you'll be able to set them up, and then use the information from section 4.1, 4.2, and 4.3. You may use elimination, you may use substitution, whatever method you want to use to solve them. So the first example, hopefully you'll start to see a pattern with these, and I'll point that out. But the first problem, it says the sum of two numbers is 67. The word sum means add. So you have two numbers, so we're going to call them x and y. And you don't have to always use x and y, but for here I'm going to use x and y for this one. The sum of them is 67. And then it says the smaller number is, okay, so let's designate x as the smaller. X will be the smaller, is, it says 3 less than the larger number. So remember I taught you when you see less than, write this in reverse order. So it'd be y minus 3. So these are your two equations. And now this is set up, in my opinion, for substitution. So if x is y minus 3, I'm going to plug that in for x in the top equation. So you have y minus 3 plus y equals 67. Then these two y's you can add up. So you get 2y minus 3 equals 67. Add 3 to 67. 2y equals 70, divide by 2. And I'm going to go fast because we have a lot to cover. So y is 35. So y we said is the larger number. So the what are the two numbers? The larger is 35. And x is the smaller, so if you plug 35 here, 35 minus 3 is 32. So 32 is the smaller. And always label your answers. And you can go back and check. Do these two numbers add to be 67? Yes. Is the smaller number 3 less than the larger? Yes, it is. So it makes sense. So you want to look at the reasonableness of these answers. Number 2. Okay, now we're going to see a series of problems that talk about numbers, like money. So we've got two things. We've got dimes and nickels. Okay, we have dimes and nickels. Let's use D for dimes and N for nickels. So then at the end, we'll know which is which, because they want to know how many of each coin you have. So Sasha has $1.65 in dimes and nickels. Look for, when you're doing this, how many individual pieces do you have of coins? You have 21 coins. So you have dimes and nickels. You have 21 of them. Your next equation is going to be, what is a dime worth? It's 10 cents. So 0.10 D. And a nickel is 5 cents. And we have $1.65. So I always think of this, money, money, money. And we have 21 pieces. So now, how are you going to solve this? What I would do, I don't like dealing with decimals. So I want to multiply this equation by 100, because I'm going to move the decimal. 2 over here, 2 over here, and 2 over here. So this equation is really 10D plus 5N equals 165. So now, if this looks like it's getting set up for elimination, I'm going to want to multiply, let's multiply this top equation by -5, because then I'll have a -5n here, and then I can add right down. So anyways, you get -5d minus 5n equals -105. And when you add, these are gone, you get 5d equals 165 minus 105 is 60. Divide by 5, and you get 14. That means there's 14 dimes. And then if you plug 14 in here, so 14 plus n equals 21, subtract 14, and you get 7 nickels. Okay, next. This one is talking about a concession stand, and we've got two things, hot dogs and hamburgers. So let's use D for dogs, hot dogs, and B for burgers. And we've got a total of, at halftime, they sold a total of 78 hot dogs and ham. So this is like the money problem. We have 21 pieces of coin. We have 78 hot dogs and hamburgers sold. Now, the next equation is how much is each one worth? Okay, so it looks like a hot dog is $1.25. So 1.25 D plus, and a hamburger is $1.50. And we sold money, 105.50. Okay? So now, how are we going to solve this? Well, some of you may want to multiply the top equation by, let's say, negative 1.25. You can do that. Or, here's another option. I'm going to move the decimal 2 over here, 2 over here, and 2 over here. So this equation is now 125D plus 150B equals 10,550. I just simply move the decimal 2 over here, 2 over here, 2 over here. It's the same equation, but no decimal. So now, if I want to eliminate, I'm going to take the smaller one. I'm going to multiply this top equation by negative 125. So you get negative 125D minus 125B equals 9,750, and it's negative. So when you add down, the D's cancel, you get 25B equals 800, divide by 25, and B is 32. B stands for burgers. So there's 32 burgers, and if you plug 32 in for B, subtract that from 78, and you get 46 hot dogs. Okay, and again, you should check, add these up, 78, and you could actually multiply 46 times the the cost of a hot dog, and 32 times the cost of a burger, and you should get 105.50. Next, okay, we are on example number 4. This is a sporting goods store. We are selling left and right-handed gloves. So let's use right hand, R for right-handed, L for left-handed, and we sold 12 gloves total. The next equation is going to be how much is a right glove? A right glove is $45. A left glove is $52. And we sold $5.61. Remember, money, money, money. So for this one, I would multiply the top equation by negative 45. So you end up with negative 45R minus 45L. Negative 45, a lot of people forget to multiply this number. You get negative 540. Keep the second equation the same. And if you add, these are gone, you end up with 7L equals 21, divide by 7, and that would be 3 left-handed gloves. And if you substitute 3 in L for L, you get 9 right gloves. Okay, next one. You're going to see quite a few of these interest problems. Okay, so we have a total of $3,000. So think of that as how many units you have. So this is a little different. X plus Y, we have $3,000 to invest. Now each account or investment earns a percent. It's like the glove problem. Right glove is $45 and the left glove is $52.